Okay, so this question here is about colorimetry, and we can see we're going to need to plot a graph, so we need to reach for our ruler. Okay, so it says an experiment was carried out to find the concentration of beta carotene in a solution using colorimetry. The results are shown in the table below. Now, at no point will we ever study beta carotene. That doesn't matter. All that matters is you recognize the word colorimetry. Okay. So we've got two columns of data. We've got concentration, that's the strength of the beta carotene, and the absorbance, okay, how much light this particular concentration of beta carotene absorbs. Okay, now I can move the table slightly off screen, but you're asked now to use the data to plot a graph on the grid below and draw a suitable line. So on the graph, the axes are given to you, the labels are given to you, and you simply have to plot the data. There's 3 points for this, okay, so there'll be 2 points for accurate plotting and 1 for a suitable line. So the first point is at 0.02 moles per decimeter cubed and at 0.1, okay, so 0.1 is going to be there, okay, which is halfway between 0 and 0.2. The next point is at 0.04 and that's at 0.2. Okay, which is there. And 0.08 is the next one, so don't fall for that. And that's at 0.4. Okay, so 0.4 is there. Then we've got another point at 0.12, and that's at 0.6. So 0.12 and 0.6, which is there. And then finally we've got 0.16, which is at 0.8, which is right at the top, which is there. Okay, so I think we can see without too much doubt that that's a nice straight line. Okay, and the line should go through 0, 0, because if there's no beta carotene, then there won't be any absorbance. Okay, so we plot a nice straight line with confidence through that data. Okay, now the way in which this is printed out is probably the reason why we've got a couple of points off the line. It doesn't matter because the overall pattern is very definitely a straight line, and that's what we would expect in one of these graphs. Okay, so for colorimetry, we're expecting a straight line graph. Now, on the next slide, it says describe how the absorbance of beta carotene changes with concentration. Okay, so I think it's fair to say that as the concentration increases, the absorbance increases. Okay, so we need to write that down. So as concentration increases, absorbance increases. So you need to simply say what you see, basically. It then says use your line to predict the concentration of beta carotene with an absorbance of 0.3 units. Okay, so we need to find 0.3 units on the absorbance scale. Okay, so this is the absorbance axis. 0.3 is going to be there. So I would make sure that your ruler is perfectly parallel to the lines on your graph. Okay, and make sure that you run a nice bold line across. When it touches the line of best fit, you drop a perfectly vertical line down. Okay, I would put an arrow on the end of it to make it absolutely clear. Okay, and then that's 0.062. Okay, so concentration 0.062 moles per decimeter cubed. Okay, and then it says it is claimed that if the concentration is doubled, then the absorbance always doubles. Explain whether you agree with this statement using data from the table. Okay, so if we have a look at data from the table, if we start off with a concentration of 0.02, that gives us an absorbance of 0.1. If we double it to 0.4, then we also double the absorbance, so it's looking good. If we double it again, then we double it again. So we can confidently agree. Okay, so that would get you the first mark, I agree. And then you can say because when the concentration is doubled from 0.1 to 0.2, the absorbance doubles from, let's get this right, oh sorry, it's 0.02, 0.04, and then okay, so let's correct that, sorry, 0.02 to 0.04, the absorbance doubles from 0.1 to 0.2, and then we could say this pattern continues through the data. Okay, so you could use any pair of those units as long as they double, because of course from 0.08 to 0.16 that's a doubling, and that's 0.4 to 0.8 that's also a doubling. Okay, so you can use any pair of combinations to illustrate that that statement is true.